Hi, today I'm going to evaluate the 5-minute rule 10 years later research paper. This work revisits a fundamental principle in computer storage, exploring its relevance in today's technological landscapes. This research paper revisits the 5-minute rule, examining its application in the context of current storage technology. Initially posted in 1987, the rule guides whether data should be kept in RAM or on disk, balancing cost and access time. Given the drastic changes in storage cost and performance, this analysis is crucial for modern database systems and computer storage efficiency. We will cover six key areas: the problem statement, the importance of the study, challenges and innovations introduced, related works, the main contributions, and the proposed methodology. These sections will help us understand the paper's impact and its implications for the field. The paper addresses the efficiency of data storage and retrieval, focusing on when it's cost effective to store data in RAM versus disk. Originally, the 5-minute rule helped make these decisions based on economic and performance metrics, which have evolved significantly with technology advances. This picture presents an overview of emerging memory technologies. Understanding the trade-offs between RAM and disk storage is vital for database management. This paper's findings are crucial for optimizing system performance and aligning with current technology trends, ensuring that storage strategies are both cost-effective and efficient. This picture demonstrates the historical cost of computer memory and storage. The paper delves into the computational complexity and data storage challenges, highlighting the novel insights into the changing economics of storage solutions. It introduces updated metrics like caps, maps, and scans, essential for contemporary storage strategies. Here is the decision-making process, which articulates the decision and gathers the information, which identifies the solutions and evaluating the solutions by choosing the solutions and implementing the solutions, and then finally reviewing the solutions. Previous studies laid the groundwork for the 5-minute rule, focusing on the cost efficiency of memory and disk storage. This paper builds on and deviates from those studies by factoring in recent advancements in storage technology, thus providing a more current analysis. This picture depicts the evolution of computer storage. This graph depicts the reference interval in minutes and page size in bytes of RAM versus disk or tape storage. Significant findings include the updated 5-minute rule for randomly accessed pages and the 1-minute sequential rule for 2-pass sequentially accessed pages. These contributions refine our approach to data caching and storage management, aligning with modern hardware capabilities. The left graph indicates the index page utility versus page size and index element size, whereas the right graph indicates index page utility versus page size and the disk performance. The paper's methodology involves a thorough evaluation of the 5-minute rule using contemporary hardware price performance data. It presents a comparative analysis with the 1987 rule, illustrating how shifts in technology and market conditions allows adjustments to storage strategies. The first graph depicts the disk performance versus time, and the second graph depicts access per second and capacity, and the third graph depicts the storage price versus time. Validation is achieved through statistical and experimental evaluations using benchmarks like TPCC reports to substantiate the theoretical models. This rigorous approach ensures the updated rules' relevance and applicability. This graph depicts the RAM size needed versus size of input file. The research methodology is robust, combining economic and technological analysis to reflect real-world storage scenarios. This comprehensive approach allows for a nuanced understanding of storage dynamics and decision making. This graph depicts the reference interval versus page size of DRAM versus disk or tape storage, reference interval in minutes, and page size in bytes. In this slide, we can able to know the weaknesses and limitations. While the study provides the significant insights, potential limitations include the variability in hardware prices and performance and the evolving nature of storage technologies, which may allow continuous updates to the rule. The paper presents practical applications and case studies demonstrating how the revised 5-minute rule can guide storage decisions in various real-world scenarios, thus proving its practical utility and relevance. The evolution of the 5-minute rule. The 5-minute rule, pivotal in database management, hinges on the cost efficiency of RAM versus disk storage. It notices the declining trend in RAM and disk prices, reflecting major technological strides. This graph delineates the cost trajectory from 1987 to 2017, highlighting the steep decline in storage costs alongside the adjusted break-even intervals for the 5-minute rule. This table describes the metric description in the year 1987 and in the year 1997 values and also the remarks. For example, the metric is RAM price per MB. It describes the cost of the RAM, but the data is not provided in the year 1987. The value is $15 in 1997 and the remarks are significant decrease in price leading to larger cache allocations. Coming to sequential access rule, it describes the guidelines for sequential data access, but it is not applicable in the year 1987. The value is 1 minute in the 1997. The remarks are it suggests faster access requirement for sequential data operations. The future directions. Future research will likely focus on adapting the rule to new storage technologies and usage patterns. Technological advancement investigates the rule's applicability in the context of emerging storage technologies like SSDs and NVMe. It explores how cloud storage economics may alter or reinforce the rule's principles. This ongoing evaluation will ensure that rule remains a vital tool for data storage management, extension to other areas, potential research into extending the rule for the other types of data access, patterns, and computational models. Personal critique. The strengths are the paper provides a robust analytical framework grounded in economic and performance metrics. It continues to be relevant through its adaptability to evolving hardware landscapes. Areas for improvement could benefit from deeper exploration into the impact of multi-tier storage and caching mechanisms. More case studies on the rules application in modern heterogeneous computing environments would enhance its utility. And my assessment of the paper is that it provides an essential update to a key concept in data storage management. However, ongoing research and adaptation will be necessary to keep pace with rapid technological advancements in the field. The information of 5 minutes rule 10 years later has been found in those references. Thank you, Pranusha Ganra.